Hi everyone, welcome to this episode of Keipert Labs. As we begin our next unit, we're going to review a concept that is something that you've definitely met before in the past, but we're going to consider it in light of what we know about matter so far. And that is, we're going to be looking at comparing pure substances and mixtures. Okay, so far some of the properties that we have been able to look at in terms of that we can measure about matter. We looked at density, this idea of mass over volume, a relationship between an object's mass and its volume. And then in Unit 2, then we've introduced these related concepts. This idea of melting point and boiling point as properties of a substance. So for example, like water, melting point is at 0 Celsius and boiling point is at 100 Celsius. And so we're seeing, we can define what these points are for a given substance, and that tells us something about how it's put together. Okay, but so what we're now going to look at is saying, all right, well, let's see what we can, when we look at these properties for different substances, let's see what it can tell us about whether it's pure or a mixture. Okay, so for example, I'm going to use the document where I'm going to try and show you a few things here. Okay, so let's say I got some iron filings and some sulfur. Okay, I appreciate the labels are upside down, but so you can see, so iron filings, so little chunks of iron metal. Okay, let's see if I can turn them around a little bit for you. Okay, so little chunks of iron metal, and then this yellow powdery sulfur. Okay, and so let's say I took these two and then I combine them together. Okay, and so I would get this. So here is a combination of iron filings and yellow sulfur powder, okay, all combined together into one container. Okay, now what we can identify is that I've just physically, I can combine these powders in any ratio I like. I can add more iron filings or more yellow sulfur, and I get a different kind of mixture. But ultimately, the iron still behaves like iron, and the sulfur still behaves like sulfur. Okay, one thing that we know about iron is that it's attracted to a magnet. So if I get, say, like my nice kind of strong sort of magnets over here, I can see that I can make those iron filings move around the container very convincingly using that magnet. Okay, I can get all sorts of pretty patterns and shapes. Okay, and so then, when I do the same thing to iron and sulfur, I get the same sort of phenomenon. Some of that yellow sulfur powder gets caught up in amongst it, but otherwise the iron is still behaving like pure iron would. Okay, so I have a mixture here of iron and sulfur, but that it's still, each part still keeps its own properties. Okay, now let's have a quick look at two other substances. So we talked about mixtures of solids. Okay, so now let's consider two other substances. So water and ethanol, which is more in everyday kind of language known as alcohol. Okay, and so we're going to look at it in a range of properties. Okay, so here is a list of some of the properties that we're going to be considering in looking at these two substances. Okay, so if I take water and alcohol, okay, so I've got pure samples of each one over here. I'm going to show you some demonstration stuff in a moment. Okay, in terms of appearance, they are both colourless liquids. Okay, so colourless and colourless. Okay, in terms of odour, water has no characteristic odour, but ethanol certainly does. When you've got two colourless liquids in test tubes next to each other, even science teachers like Mr. Keipert sometimes use that to quickly tell them apart. Okay, we know that water is not flammable. That's the whole, one of the reasons we use them in fire extinguishers, whereas ethanol, alcohol, is. Okay, so we can see that these two things are different on these kind of very subjective sort of terms as well. But so then we also can add in our three extra kind of properties that we have here. Okay, so what we have is we know that water's density is around about 1.0 grams for every 1 mil. Okay, and so what we have over here is that ethanol's density is around about 0.8 grams per mil. Okay, so if the question I put to you, okay, so if I have three test tubes here, okay, what I've prepared, I've got water, and in the middle is just pure ethanol, and then on the right hand side is a 50-50 mixture of the two things. Okay, so if I get 50 of half of this and half of this, it's quite reasonable for us to expect that its density might be around about 0.9 grams for every mil. Okay, so it's somewhere around about in between. Okay, so the mixture of the two liquids is behaving a little bit like that. And likewise, if we can add in an extra kind of property that we can observe here. I'll put it down the bottom of the table because I've already got it constructed. Is this idea of solubility? Okay, so if I take the 3 samples that I just showed you, and I'm going to add in some blue copper sulfate crystals. Okay, just like the sort of thing that you've used before all the time. Okay, I apologise if it gets a little bit hard to kind of see what I'm doing here. I'll do my best. Okay, so this is my water. Okay, if I take some water, take the crystals of copper sulfate and I put them in the water, okay, very quickly I get slightly blue water. Okay, all of those crystals, bar a couple of stubborn ones at the bottom that just haven't had a chance to unstick, have dissolved. Okay, now if I do the same thing with my ethanol, and take my blue crystals and I put them in, give them a shake, and flick my test tube to try and encourage everything to mix. Might even give it a little bit of a shake up like this. I end up with blue crystals at the bottom, okay, that they stay undissolved. So, take a moment to think about what's going to happen if I've got a 50-50 mixture. Okay, if they dissolved easily in water, they didn't at all in ethanol. Okay, so give them a swirl, give them a mix, give them a little bit of a shake. Apologies if this is making you dizzy. Okay, so I end up with slightly blue water with some blue crystals down the bottom still. Okay, so the solubility was yes, no, and then we might say half. Okay, so now, then let's have a look at our melting and boiling points here. Okay, so water melts at 0, ethanol melts at 117. Water boils at 100, ethanol boils at 78. So if we're working on this premise that a half and half mixture has properties kind of halfway between, then we might expect this to be about minus 55, and then we might expect this to be around about 90 degrees Celsius. Okay, but so then let's have a look at this. So here is a graph of, if we take that, take a sample 50-50 mixture, like the one that I showed you just before, and we boil it. We use a process called distillation. What you can see is that the temperature very quickly rises from room temperature up to around about 80. And then we get this wiggly sort of plateau that's distinctly lower than 100. And then we get to a certain point around about 14 minutes on this graph where then the temperature starts to climb again. And then it plateaus at just over 100 for some time. So what's happening here is that we're actually we're boiling in 2 stages. We're getting ethanol boiling at one point, and we're getting water boiling at a separate point. So those 2 temperatures relate to their individual boiling points. Okay, so in this particular situation, that the boiling point here, the melting point is harder for us to measure in the lab. The boiling point here is not somewhere in the middle, but actually that we get this sort of process happening where they each boil separately. One first at a lower temperature, and then once that's done, then the other. So what we can see is we can use this difference in their properties as a way to actually separate a mixture of 2 substances. We could use, with our mixture of iron and sulfur, if we were so inclined, we could use that magnetic property as a way to separate out our iron filings from the sulfur, which did not attract a magnet. We use this technique to separate water from ethanol. That's how how spirits are made. Things like vodka and gin are used by distillation of a kind of a complex watery mixture to remove as much water and to collect as much alcohol as possible in a separate place. Okay, and so so we can see that mixtures we can use the properties of the parts of a mixture to help separate them, whether it's solids and solids, liquids and liquids, and we can use these differences in these physical properties to separate all kinds of mixtures. Alright, thanks very much for watching. Time for a meme of the week. Bye for now.